Alright, so we are going to go through this homework, which was the back of the 1.1 vocab sheet. I'll go through the answers, give a little bit of explanation for why things are the way they are, and then you'll be ready for next set of notes. So here we go. A lot of these terms and ideas were found on the vocab sheet that we had. Starting with undefined terms, a point. Both of the classes said that the point had 0 dimensions, which was correct. We represent a point by a dot. And there on the right side, you can see an example and how we would name one as well. Line A has, in this case, in all cases, 1 dimension. It is represented by a line with 2 arrowheads, but extends without end. Remember that we need 2 points to make one line that couldn't be recreated any other way. And we can use any of those 2 points on a line to name them. One thing that we should also mention is that you can name lines by their points, as is being done here and here. But one thing that didn't really come up in the vocab lesson that we went through was that you can also name a line by a lowercase letter as a name for the line. Right here on your sheet, you have a fancy cursive L. That L could also by itself be the name of the line, as we see right here. And then we have a plane, which has 2 dimensions. Looks like a floor or wall, extends without end. We need 3 points, this is key, that are not on the same line in order for us to be able to say that there is a plane. We need 3 points, though. Has to be 3 points. So, using these ideas with these true or false questions on the side, would it be accurate to say that another name for line CE is line N? Well, C and E are 2 points that are along this line, and we see here that N is also the name of the line. So that one would be true. Is it true that rays E and F, that rays EF and ED are opposite rays? Well, let's investigate a little bit. Ray EF would be a ray starting at E and extending up towards F, and ray ED would be a ray starting at E and extending towards D. While these are both rays that start at point E, remember for opposite rays, they need to form a straight line with each other, but EF and ED form an angle, not a straight line. So these are not opposite rays. All right. So let's see this one. Another name for plane A is plane CED. So here we see a bold A. That can be another way to say the name of a plane. It's a little bit darker than all the other letters. CED. Here are CE and D. This would be okay, except because we do have 3 points, but the problem is CE and D are all the same line. And the reason that we can't use that to name plane A then is because I could make many planes that go through those 3 points. Like if I made this, kind of using that line as a barrier, there's another plane that goes through CE and D, but it's not the same one as A. So we can't use CE and D to name plane A because there are an infinite number of planes that we could create that also have to deal with those places. Points C and F are collinear. Now, in my past experience, when I've asked this question to students, a lot of them have said that this is false. But it has to be true, because even though there's not currently a line between them, C and F are 2 points. And as we wrote over here, I'm going to refer to the left side of the sheet again. Through any 2 points, there's exactly one line, which means that we could easily create a line that went through F and C. So this one is true. And for that same reason, points D, B, and C, well, those ones are clearly coplanar because they are on the plane that's on the sheet. But F, E, and D are 3 points, and any 3 points have to be coplanar. So F, E, and D are also coplanar. If we were to add a 4th point in, they would not necessarily be coplanar, but if you only have 3 points, they have to be. They are coplanar. There is no way to make them not coplanar. All right, so then we have this part down here. 2 other names for LN, line LN. Well, we could easily just switch the letters, and we could call that, let me write this down here, we could call that NL with those symbols, but we could also call it line B, that lowercase b that's there. Plane Z, we could give a few names. We could call it plane PLN. Those are 3 non-collinear points on that plane. I could call it MNP. But notice that both of these names use P because it's not on that same line as L, M, and N. And there are a few others that could work too. Then we have to, for part B, name 3 points that are collinear and name 4 points that are coplanar. 3 points that are collinear, we have L, M, and N. And points that are coplanar, I'm just going to take those same ones. And I'm going to add in P because those all exist on the plane that is Z. All right. So we have the checkpoint over there on the side. First, we have to give 2 other names for MQ, and then name a point that is not coplanar with L, N, and P. All right. So 2 other names for MQ. We could always call that QM. Just switch the letters around. And also, we can see that there is a letter for the line, a lowercase letter. And we see that it's a lowercase a. So we could call this line A. Name a point that is not coplanar with L, N, and P. Well, Q is clearly above that plane. So we could say that Q is not coplanar. It's not the same plane as those. All right, last section of this sheet. Give another name for line segment VX. Well, remember that with line segments, it's always safe to just switch the letters, as long as it's not a ray, so XV is fine. The rays with endpoints, with endpoint W, so we have WY, there's the ray symbol, WV, WZ, and WX. The opposite rays with endpoints W are, well, let's make this a little bit easier. So, just so that you can check to see if you got it right, the ones circled in green are opposite rays of each other, and the ones circled in blue are opposite rays of each other. So those are the 2 sets of opposite rays that we have. Another name we can give for YW, again, we can just switch that order, switch it to WY. Are VX and XV the same ray? Well, let's think about that for a second. VX is a ray. Let me erase a little bit first, just to make the picture clear again. So VX starts at V, goes towards X, but XV starts at X and goes towards V. These are clearly not the same ray. But let's look at the second case. If we have a ray that starts at V and goes towards W, never ending, of course, because it's a ray, and then we have a ray that starts at V and goes towards X, notice that those are the same ray. So it can happen that we have 2 different names for the same ray. You just have to sort of be careful about how you set it up. or else you could create something that just does not work. All right, so those are the answers to the sheet and a little bit of explanation as to why. You'll have a chance to ask questions if you still have them a little bit later. But for now, move on to the notes for section 1.2.